Everyone, and thank you for joining this platform demonstration presented by ThreatX. I'm your host, Jeremy Ventura, Director of Security Strategy and Field CISO. And today we have an exciting and interactive demonstration and presentation that's going to actually highlight the querying language of GraphQL, its rapid adoption in the industry, the security risks behind it, and also finding a live demonstration on how ThreatX is able to identify and protect against GraphQL threats. But I'm not alone. Today I actually have the privilege of presenting with Mr. Nick Aleks. Nick is the co-founder of DEF CON Toronto. He's also the co-author of his latest and newest book, Blackhat GraphQL, and he's also the Director of Information Security for Weldsimple. So Nick, thank you for joining me today in this presentation, and super excited to have you here.
Likewise, Jeremy. Thank you for having me here. Thank you to the ThreatX team. I'm super thrilled to be able to do some live GraphQL hacking here and to put ThreatX to the test and see how we can block some of these attacks.
Awesome. Look forward to it. Well, let's get right into it. So first, where I want to get started is to give a baseline and understanding of who ThreatX is and the platform that we provide for our customers. Really, what we're trying to do is help all organizations of all sizes and industries manage their APIs and application protection in real time. The first thing that we do is we visualize, inventory, and discover your APIs that are within your threat stack. From there, we detect threats that are happening across your environment. What we do next is track those behaviors over time and find abnormalities in that, really producing the prioritization of where to focus on. And lastly, what we do is we are able to block real-time threats. ThreatX wraps this entire solution around what we call a protection as a service. So what does that really mean? In the world we live in today, organizations are really struggling when it comes to retaining employees or even hiring. So what we do is we provide an out-of-the-box managed 24/7 support system that can help you do all those different functions, such as visualize your APIs, detect those, and block those. So what we're doing is we're monitoring and we're responding in real time to your emerging threats, really be an extension of your security team. So that is ThreatX at a high-level overview. And what we're going to get into now is Nick's overview of Blackhat GraphQL, the book he created, and also GraphQL in general and the security risk that it poses to this industry. Nick, I'll let you take it away from here.
Blackhat GraphQL is one of the latest additions to the Blackhat arsenal as part of the No Starch Press publication for hackers and for bug bounty researchers. The book is curated for pen testers who may or may not have heard of what GraphQL is and how GraphQL APIs work. We wrote the book because we started to notice an uptick in the number of GraphQL applications that were out there. Weldsimple is a big customer, but we've also noticed that other organizations such as Shopify and even GitHub and PayPal are starting to use the GraphQL API as a way to serve data to some of their consumers. Now, we started to do some online research to see what kind of security techniques are out there on how to harden the GraphQL application layer. And we noticed that there wasn't a lot of resources out there. So we did what any group of hackers would have done, and so we started hacking it ourselves. The book itself is a collection of roughly 2 years of research into hacking and breaking GraphQL, and it also highlights some of the open source tools and utilities that we wrote that allow you to automatically test against it. Some of the things that you would be able to do in the book highlight things such as being able to build your own GraphQL hacking lab, as well as a full suite of tutorials on how to inject data, exfiltrate data, all within this brand new world that we call GraphQL. Now, one of the most important tools highlighted in the book is known as DVGA. I'm going to showcase it right here. DVGA stands for the Damn Vulnerable GraphQL Application, and it's a tribute to the Damn Vulnerable Web Application, DVWA. Now, we wrote DVGA as a tool and a resource for us, as well as other hackers, to be able to feel comfortable with breaking a GraphQL system without getting charged for breaking into another organization's GraphQL API. This is an intentionally vulnerable GraphQL application that has a whole suite of different vulnerabilities and weaknesses that really allow you to test your skills when it comes to breaking GraphQL applications. What I have here on the screen are actually two versions of DVGA. One version that I'm hosting, which is raw and as vulnerable as can be. And the second version that I have here, DVGA2, is a version that's hosted by my friends at ThreatX. Jeremy, do you want to talk a bit about how ThreatX is protecting the second version of DVGA?
Absolutely. Thanks, Nick. So as Nick mentioned, ThreatX is sitting in front of that second DVGA application that Nick has created. So what does that really mean? So ThreatX is architected in a reverse proxy manner. So what we're doing is we are looking at all the HTTPS traffic that is coming in, being able to analyze that flow, understanding, is this an application? Is this an API? From there, what we're doing, as I mentioned before, identifying the behaviors that we see based upon different rule configurations and rule logic. And so what we're doing is when you'll see Nick do his demo, we'll be able to see that traffic come in, identify that it's GraphQL, and then from there, because we're in a reverse proxy state, be able to take action on that. And now the real fun begins. Nick is now going to actually demonstrate some of the different attacks, and you'll see how ThreatX can protect against these GraphQL threats. Nick, all yours.
All right, let's do this. Okay, so the first thing I'm going to do is I'm going to showcase a tool here that we have called Altair. Now, Altair is similar to Postman in the sense that it's able to interact with GraphQL servers. It acts as a type of consumer or a client, and it's a really easy way to write GraphQL queries and to send those requests to a GraphQL server. So, as you can see here, I currently have DVGA2, which is the unprotected version of the damn vulnerable GraphQL application. Here we have a very simple query that I'm going to be sending to the DVGA instance, and as you can see, I'm going to be querying for all the pastes within the DVGA database. Here I have a filter that's searching for my first paste, and some of the fields that I'm going to be looking to get back from my paste object within the server is the ID, title, and content field. Let's go ahead and send this request. So, as you can see, the server came back with a 200 OK response, and it gave me the ID of 1, my title, which is testing, and the content of my paste, which is my first paste. So this is, a typical sort of a happy path for how GraphQL is used. Now, I want to do something malicious and try injecting some SQL payloads within this filter parameter. So I'm going to go ahead and in this parameter, and instead of saying my first paste, I'm going to see whether or not I can potentially inject some SQL here. What we're first going to do is I'm actually going to just submit a single quote. This is often the case for when you want to fuzz and look at what type of parameters may be injectable within an application. So I'm going to go ahead and just send this single quote. All right, the response that I got back here is very clearly a SQLite error. When we see this type of error, we kind of have this inkling as hackers that there's more to it. We can definitely do some SQL injection, and we can potentially retrieve more information from the database than we're supposed to. So let me go ahead and after this single quote, add some very juicy SQL injection here. And essentially what I'm doing is I'm essentially breaking out of this filter logic, and I'm adding an additional condition called or 1 equals 1, which means I will be getting all the pastes from the database and not just this one that I'm particularly filtering for. So let's go ahead and click send. And as you can see in my response here, I've got all the pastes from the DVGA application, not only just my own, which has the ID field of 1, but I also have another one here with the ID field of 2, 3, 4, and I can even see things like phone numbers in here. So as a hacker, this is definitely a really juicy finding and something that would allow me to reap a very juicy and pretty big bounty in some of our bug bounty campaigns that we're a part of. So I'm going to go and now run this exact same payload against the ThreatX protected version of DVGA. So I'm going to go ahead and copy this payload, go to my second tab here within Altair, and as you can see here, this has the dvga.dev subdomain, and this is the protected version. So I'm going to go ahead and paste this SQL injection payload and click send. But instead of that 200 OK response that I got, instead I got a 403 error. Jeremy, do you want to talk a bit about why I encountered this error?
Absolutely. So as designed, ThreatX being able to sit in front of that application, that is the expected behavior you saw. So as Nick performed that attack against us, acting as a reverse proxy, we were able to identify that threat and automatically say, nope, based upon the action, we are stopping him in his tracks. So we had blocked Nick out from trying to harness or trying to infiltrate that application with his SQL injection attack. And again, that's all because of the way we're architected as that reverse proxy, really acting as that next-gen web application firewall within your stack. Okay, so now what we're going to do is pivot into the ThreatX dashboard. So what you're seeing here is the main attack dashboard home screen for all users. What you can see at the top here is all trending metrics that are happening over time. So what is the traffic that's going on that is seen within my environment, and what percent or what of those requests are actually being blocked? As I scroll down, what you'll notice is all these different entries that are showing all the different types of attacks that ThreatX has monitored and detected. What you notice is in the first column, we have something called a threat entity name. As you can see, what we do is highlight and classify every single attack with a classification or an entity. Here in this case, Sweltering Avery is actually Nick. And we can tell because a couple different things. One, his IP address. Nick is actually calling in and performing these attacks from Canada. So this is actually Nick's IP address right here. And in addition to this, if I scroll over to the rules, I can actually see that SQL injection attack rule being triggered. As I click through this and as I view some of this information, ThreatX also provides you a bunch of different avenues and different ways to kind of slice and dice visually this information. You can filter by attack class, you can look at different max levels, and you can also sort by last seen to help you prioritize what is happening most recent in my environment. From here, the way ThreatX works is we just don't provide the information. We want you to allow your users to deep dive into the details. So as I click into Sweltering Avery, what I can see is a bunch of different metadata that's happening. I can see his IP address again, his location, his user agent. So Nick is actually on Chrome using a Mac. And as I scroll down, I can then see all the different timeline of events that's happening within this specific IP address. If I click into any single one of these events, what I'll see is all the different parameters that we're able to provide, such as what is the full path, what was Nick's full TLS fingerprint, what was his full user agent string, and then again, all the different signatures that were matched. So this was, again, a GraphQL scan detection SQL injection that we saw based upon Nick's activity. Why this is important is because this information can be used, especially when we talk about data correlation or getting this information to the right people or right tools and technologies. The more information, the more data you have, the more power you have to do different things such as investigation and respond. So as you can see here, ThreatX was able to track, identify, and then also block based upon this information, based upon the rule, Nick's GraphQL injection attack. Now, the next thing I want to do is actually take a look at another different type of dashboard that we have. This is called the API catalog. What we're seeing here is all the different applications or sites that we have that are monitoring this environment. We have different ability for organizations to come here and actually click on certain sites and filter. So for example, this DVGA app that Nick was mentioning before, I can sort by this and just get a view into what's happening specifically with this application or site. From here, I can see all the different types of attack classifications, the total endpoints, and then all the other API profiles in your network. Notice GraphQL right here at the top right, and we see this one count. From here, I'm then able to click into the site itself and then see all different trending and benchmarking that's happening over time. In addition to this, I can also see all the different endpoints that would be listed. Now, in a real production scenario, you would probably have tens, if not hundreds of separate endpoints that would be listed here based upon the application and the site itself. Again, same information you're seeing before. We can profile the different type of API this is. We can then look at what the attack class is, how many threats, and then how many rules and how many block requests are happening, providing you the prioritization again to know what to focus on first. If I click into this GraphQL endpoint, Again, what I'm seeing is all different types of detailed information about the traffic trends within this application. But then I also can harness into the information about the specific threats. And then there it is again. You'll see Nick here as Sweltering Avery with his IP address. And the same view before, by clicking into the specific entity, I can get all the detailed information that I want to see. Nick, I'm now going to turn it back over to you to do your second demonstration.
Thanks, Jeremy. I'm excited to get into some more hacking demos here. The second one being a very GraphQL specific attack. As we know, SQL injection is a traditional attack. Let's talk about something new, something GraphQL focused. And why not talk about the 0-day vulnerability that both myself and Dolev uncovered, and it is called directive overloading. So what is a directive? GraphQL provides clients with a way to manipulate how they want their data to be perceived by the server, as well as responded back from the server. So for instance, if I wanted to get all of my fields in a capitalized syntax, I could append the @capitalized directive after the field. So let me show you how that sort of works. As you can see here in Altair, I have my query request on the left, and I have a very simple query, and it's looking for the type name, and it's directly querying the schema of DVGA. Now, to add a directive to a field, as I mentioned, you would just use the @sign followed by some sort of directive that you want. Now, GraphQL has a couple of built-in directives, such as skip, but we're not going to include that. We're going to include something random like AA. Now, if I go ahead and I click send here, you can see that DVGA didn't really like that. Its response back was 400 bad request, and it said here that it doesn't know what the AA directive is. Now, one of the things that we wanted to maybe test out is how many directives can DVGA handle. So let's add a couple more. So as you can see, the more that I add, the larger the response from the server gets. It's actually quite explicit, telling us exactly what directive it's unsure of and what line and column within our GraphQL document it's complaining about. So as you can see, the more directives that I add here, the larger the response. So I'm going to go ahead and copy a really large payload here. And I'm going to go ahead and paste it. Now, this right here causes a denial of service attack against a GraphQL application. Now, the number of directives that we're sending here aren't going to exactly crash DVGA, but cause it to sweat a little bit. Now, the number of directives you add is proportional to the type of resource consumption and CPU consumption that the server would experience when sending the request. You can imagine that if you were to send a really large request with tons of directives, you could potentially even crash the server. So let's go ahead and send this request. As you can see, that took a little bit longer. That took 800 milliseconds there. This type of attack is really hard for a lot of GraphQL implementations to protect against. And we're going to go ahead and send this exact same request against the DVGA environment that's protected by ThreatX here. So let's go ahead and send this request. And as you can see, we have a 403 response, just like we did with the SQL injection attack. Jeremy, do you want to talk about how you blocked this one?
Absolutely. And as expected, again, as Nick mentioned, we stopped him right in his tracks. So the whole goal here of ThreatX is to stop attackers and hackers like Nick from attacking your applications, whether it's directive overloading or other types of GraphQL threat entities and threat types. And so, again, the reason we did that and the reason we were able to block that traffic was acting as that web application firewall in that reverse proxy manner, sitting in front of the application. Again, identifying that Nick was using measures of GraphQL, and then he was going and looking at different types of directives and trying to overpower our system. What I'm going to do now is actually show you into the ThreatX dashboard, kind of that ruling configuration that I mentioned earlier, but what is the logic behind how ThreatX is able to stop some of these attacks? So now I'm going to pivot back to the ThreatX dashboard and show you that rule configuration. Okay, so now we are back at the ThreatX dashboard. And as I mentioned, I want to show you the rules and logic of how ThreatX is able to identify NICS attacks and then also block those. So what I'm going to do is go into the settings tab here and click on rules. You can see all the different rules that are provided out of the box and some that are also customized for this specific demo tenant. Organizations will have the ability to leverage a lot of the out-of-the-box ThreatX rules, but also be able to customize depending on their industry, depending on the certain types of attacks that they're seeing. For this specific one, we want to look at this GraphQL block directive overloading. If I click on the edit rule details of this, I can view a visualization of how this rule was actually created. But in addition, what we commonly see is individuals and developers creating these rules using JSON formatting. So what I'll see here is the actual logic behind how this rule was triggered. The first thing we're looking for is, does GraphQL, is it contained actually in the URI? From there, we can see a regex match here of all the different directives, for example, or lettering or numbers that Nick was using. Notice here the 5. Any single time Nick went above 5, what we were going to automatically do is apply this rule. From there, we use Boolean logic to say, if this happens, what should we do? Notice the action tab here. We have the ability here at ThreatX to be able to track attackers over time. We can also block them outright, or we can do other types of methods, especially when it comes to bot activity around tar pitting and slowing down the attacker. But notice in this one, based upon the rule JSON logic, we said if this rule is seen and triggered, the action we want to take is go ahead and block. And that's exactly what you saw on Nick's output when you saw the 403 happening here. And what you also saw within the ThreatX dashboard, that Nick's threat actor was blocked. So that is a little bit with the ThreatX dashboard, and also Nick's. Thank you for doing those awesome demonstrations and trying and attempting to attack ThreatX. But we did stop you, so better luck next time. But I will turn it over to Nick for just final thoughts on GraphQL and his partnership with ThreatX.
Thanks so much, Jeremy. What I highlighted was just a small fraction of the attacks and tools and techniques that I've got under my belt. And I'm more than welcome to come back if the audience so wants me to, and to run more attacks against the ThreatX platform. Now, what's really important about GraphQL specifically is that traditional security tools out of the box will fall short of protecting against GraphQL attacks. As you saw in the ThreatX platform that Jeremy showcased, companies are going to need to invest in either their own WAF rule sets or their own internal security engineering teams to be able to detect and prevent against GraphQL attacks. GraphQL is still relatively new technology, and the attacks that are highlighted in the book are only going to get more popular and only going to run more rampant. Now, I want to leave everyone with this message here, which is if you're using GraphQL APIs and you haven't picked up either a copy of the Blackhat GraphQL book or are familiar with some of the tools that Dolev and I have highlighted in the book, please go ahead and start digging into some of these really rich open source and openly available resources that we've developed for the community to best protect against GraphQL particular attacks. Now, I'm going to kick it back over to Jeremy and leave everyone else with continue hacking the planet. And thank you so much for your time.
Awesome. Thank you so much, Nick. Again, thank you for joining us on this product demonstration. We're super fortunate to have you. And as Nick mentioned, please, everybody, go out there and grab a copy of Nick and Dolev's latest book, Blackhat GraphQL. You can also follow Nick on LinkedIn. And then also, please check out the ThreatX website at threatx.com to find out more information about how we're protecting our customers against APIs and applications. So now what we're going to do is we're actually going to turn this over to a live Q&A here. So please, anyone in the comments, if you haven't already, please be posting your questions. And what we're going to do right now is we are going to do a little session between Nick and myself and answer some of the questions that have come in. So send them in. And again, thank you very much for joining. And we look forward to answering these questions. So here we go. Perfect. So we have a couple questions in the chat. Nick, I'm going to start with the first question. Can you provide us any other examples of how GraphQL APIs are being attacked besides the two that you demonstrated today?
Yeah, for sure. The two that I highlighted were injection attacks as well as denial of service, but GraphQL is also attacked in a various slew of ways. Some of them include information disclosure attacks, request forgery, and hijacking. But the one that's really running rampant now these days is around authentication and authorization bypasses. A lot of organizations and dev shops that are using GraphQL have made a conscious decision to actually embed authorization and authentication logic right inside of their GraphQL API layer. This essentially allows for certain requests to come into an authenticated front door and allow for clients to either have access to a resource or not have access to a resource. Now, some of the things that I've highlighted is that GraphQL is it's very forgiving and it gives API consumers a lot of power. And with that power comes a whole whackload of attack avenues. So, for instance, in the traditional REST API world, we like to think that one request equals one action. So if I send a post request to create a user, I will only create that one user with that one request. Now, in the GraphQL world, that's not necessarily the same thing. One HTTP request can actually do a lot of actions, and that's perfect for things like enumeration, activity. So looking to see whether or not you can access certain resources in an API, or even doing brute forcing attacks with just one single HTTP request. And that's like a superpower when it comes to hackers. So authentication and authorization attacks are one of the biggest vectors for a lot of attackers to break into GraphQL APIs, and is one of the beefier parts of our book, of one of our chapters in our book, Blackhat GraphQL. There's a number of tools also that we've put together and highlighted in the book that help with automating a lot of these authentication and authorization fuzzing and brute force attacks, such as CrackQL, a tool that we wrote and open sourced. So there's a slew of different methods and tools that you can use to test how secure your in-band authentication and authorization controls are within your GraphQL API. That's one thing that I would definitely
Awesome.
want to
Oh,
share.
thanks, Nick. I think we've got time just for one more quick question here before I turn it over to Sydney. We have a lot of viewers that are red teamers or pen testers or looking to get into the industry. And one of the things that excites them, and it's a way to make technically some money here too, is doing bug bounty programs, especially with big tech companies. And I know you mentioned a lot of the work that yourself and also Dolev, the other co-author of Blackhat GraphQL, did. But can you just give a high-level experience of what was that like working with some of the big tech companies and bug bounty programs? It's a really cool experience. I think a lot of viewers would love to kind of get a little bit insight on what was your experience like.
Yeah, really good question. Naturally, as hackers, when you stumble across a novel exploit or a vulnerability that no one else knows about and pretty juicy, you immediately go to HackerOne and BugCrowd and all these other bug bounty programs to start searching for companies that use GraphQL. And we came across a lot of major organizations and tech companies that everyone knows about: GitHub, PayPal, Shopify, Starbucks. All these organizations use GraphQL. So we immediately started to submit a lot of findings to these types of organizations. This is only going to grow, especially as GraphQL grows in popularity within a lot of dev circles, and it's seen as something that slowly is going to replace a lot of REST APIs. These massive organizations are only going to include them within the scope of their bug bounty programs. The process was definitely interesting. Going in and submitting a finding, any sort of finding requires a lot of proof of concepts, a lot of educational material. But when it comes to GraphQL, a lot of security engineering groups are maybe not as equipped as they are to traditional like REST API attacks. So there's a lot of like back and forth education that Bill and I had to do in order to ramp folks up to say like, yeah, this is a concern, this is a vulnerability. yes, it's not really something that would work in the REST space, but you have to do a little bit of GraphQL education and highlight some of those findings. Every single one of the organizations that we submitted findings to were able to quickly expedite the recovery or the remediation of the vulnerabilities, and were an absolute gem to work with. Definitely big shout out to all these organizations who are looking at GraphQL and using it, and responsibly investing in securing
Yeah, no, thanks
it.
for sharing. That's awesome it's awesome to get great insight into kind of what that process was for you. So thanks for sharing. Of course, the live Q&A is about to end here, but if there are any additional questions, please feel free to leave comments. Nick and I will be monitoring that and can always answer live through the comment section here within LinkedIn and other platforms and get back to you. Nick, again, thank you so much for joining us. And without further ado, I'm going to turn it over to our Senior Product Marketing Manager, Cindy Cafaro, for a quick wrap up and some giveaways. Cindy?
Thank you so much, Jeremy. Just wanted to remind everybody to get your copy of Blackhat GraphQL, authored by our own Nick, Aleks, and Dolev Farhi. Like Nick mentioned, they have multiple chapters on various different topics for GraphQL, as well as GraphQL-specific labs, and GraphQL tools that they developed alongside the book as well. So can't emphasize enough to get your copy of Blackhat GraphQL. The last piece that I'll also mention is, as a thanks for joining our platform demonstration, ThreatX is giving away ThreatX hacker hoodies to a select few attendees. Again, we appreciate everybody for joining today's event, and please be sure to follow along the ThreatX LinkedIn for future product demonstration events. So thank you everybody for joining. Thank you, Nick, and thank you, Jeremy, for the event, and we look forward to the next one.